Hello everyone, this is Machine Learning Project of Group 26. Our topic is text classification. And this is our main contents of this presentation. In the first part, I would like to introduce our background. Text classification is one of the natural language processing problems. In our project, we classify Chinese news headlines into 10 classes. Then we perform data preprocessing and train 3 models, which are TestCNN, FastTest, and BERT respectively. In the following sessions, we demonstrate what datasets we use, how we preprocess the data, train different models, and evaluate models by accuracy.
The dataset used in this project is obtained by THUC News related to Chinese news headlines and by Sogo News, respectively from GitHub. The dataset includes 10 categories and each category has 20,000 samples. This dataset is divided into training set, test set, and development set, which contain 180,000, 10,000, and 10,000 samples respectively. These 3 datasets are divided as follows. Next.
Okay, and for the data pre-processing, before we use the data to feed the model, we need to do some data cleaning and convert word-to-word embeddings. Firstly, we build a frequency table. That means we divide words and space from the text, and then mapping from words to frequencies. And we take the first 100 words. The second step, we need to design a pad size and make a supplement or cut to ensure that the size of each sentence is consistent. Then we add the mapping of unload characters and fill characters at the end. After this, we could convert the data to tensor. And here is a sample output for trained data in different models. In TextCNN, the format is like this, which X represents the word line and the label and the sequence length. And in other models we used, like FastText and BERT, are a little bit different. Since the FastText adds an n-gram and the BERT get embeddings from the pre-trained model and use masked language model.
We totally use 3 models to perform text classification. First, let me introduce TextCNN model. The idea of a convolutional neural network is to capture local features. For text, a local feature is a sliding window composed of several blocks. It can automatically combine and feature n-gram features to obtain semantic information at different levels of abstraction. The structure of TextCNN model is shown below, which is composed of embedding layer, convolution layer, pooling layer, and fault connection layer. Next. We first input batch size sequence length to the TextCNN model. When reach the embedding layer, the pre-training word vector is loaded. Then we extract feature with multiple convolutions. To extract 2-gram, 3-gram, 4-gram information from the dataset, we set the size of the convolution corner as 2, 3, or 4. After convolution, we obtain 3 feature diagrams. Then the feature diagrams will maximally pooled and split into a single dimensionless batch size as 300. Then there is a full connection layer. Finally, based on softmax normalization, the class corresponding to the largest number of predict categories is taken as a final prediction. And the experimental result shows that the loss of the text set is 0.3 and the accuracy of the text set is 90.75%. The loss and accuracy are shown in the figure. The loss of text set and development set is reduced to a relatively low level after about 300 iterations respectively, and remains unchanged around about 4,500 times. As can be seen from the results in the table, the precision, F1 score, and recall of all news categories of this model are all higher than 0.84. Among them, the classification accuracy of education and post-news is relatively high. Next.
And then let me introduce the second model we use is FastTest. FastTest is a word vector calculation and text classification tool open sourced by Facebook in 2016. It is very popular for NLP tasks with its high accuracy and limited training time. Before introducing about model structure of FastTest, I would like to introduce two key ideas of this model. The first key idea is n-gram. In NLP tasks, the individual words in the vocabulary list are often used as basic units for training and learning. However, low-frequency words and rare words may not get enough training because of their less appearance in the corpus. In addition, if there are some words that have not appeared in the dictionary or words with certain spelling errors, the traditional model may be powerless. So n-gram is introduced in the FastTest model. It breaks up a word to the character level and uses character level n-gram information to capture the sequence relationship between characters, hoping to enrich the more subtle semantics within the word. While the model is training, each n-gram trains a corresponding vector, and the vector of the original words is obtained by summing the vectors of all n-grams. All word vectors and character level n-gram vectors will be added together and averaged as input to the training model. Since the original space of n-grams is too large, there are more parameters that need to be estimated, and the model may be expanded. In our project, we use a hash trick, which means that n-gram information is mapped to fixed size buckets with a hash function to achieve controllable memory. And here is the example of n-grams. And using n-grams increases accuracy in our experiment. And we can see from the table that the model added bigram and trigram perform the best in our task. The second idea is hierarchical softmax. We all know that softmax is the promotion of logistic regression in multi-classification tasks. It is often used in the last layer of the neural network. The hierarchical softmax idea is to transform a global multi-classification problem into zero binomial classification problem, which can be reduced complexity greatly. We can see in the picture that each middle node marked in gray is a logistic regression unit. Based on the unit's output, hierarchical softmax can choose the next step of the tree. It can choose to go left or right depending on the probability of each unit and finally find the word. The probability of the final output word is equal to the continuous product of the probability of zero logistic regression units in the middle. The input of FastTest is n features which are embedding an average to form the hidden variable. Then the hidden layer consists of fully connected layer and value function. At the last, the model goes throughout another fully connected layer and uses hierarchical softmax to go output, which can be reduced model training time with respect to softmax. And here is the FastTest model structure. And first we get the inputs to the FastTest model, and then reach the embedding layer and splice embedding layer. Then we get the mean of the words and fit it to the fully connected layer and value function. And lastly, we feed it to the fully connected layer too and get the hierarchical softmax to get the result. And here is the experiments and results of our fast test model. The first two figures show the accuracy of development dataset and trained dataset. The last two figures show the loss of them. And we can get 92.19% accuracy in our experiments of this fast test model. In the table, we can see the record FE score of all news. And we can see that the classification accuracy of the sports news is relatively high, achieving to 97%.
Okay, the third model we used is BERT, which structure is based on the original implementation of multi-layer bidirectional transformer encoder blocks. The inputs include 3 embeddings. Each token has a token embedding, a segment embedding, and a positional embedding. Their sum is fed to the BERT, and its training used in 2 tasks: masked language model and the next sentence model. And in this part, we used 2 models. Model 1 is a BERT pre-trained model, and then we added a fully connected layer to get the output. And what's more, in order to enable the extracted features to capture more information in the sentence, Model 2 is a BERT CNN network model based on the combination of a pre-trained BERT network and the CNN network. Then we do fine-tuning in 3 aspects: batch size, learning rate, and the number of epochs. The table indicates the different accuracy on different learning parameters, and we can find changing the batch size properly can more significantly influence the accuracy of our BERT model than 2 parameters. And then here is the change of loss and accuracy. We finally get the 94.69 accuracy. And then in different levels, there are some differences in accuracy. The classification accuracy of the sports and game is relatively high among all the category, achieving to about 95%. On the basis of BERT fine-tuning, we set suitable parameters. Then next please. Then we add a CNN network to classify the Chinese text. We add 3 convolutional layers and go through a ReLU function, then enter the pooling layer. The accuracy is 94.34. Compared to the original model, is a little bit down, so it's not effective in improving the accuracy of the classification.
Then we move to the conclusion part. In this project, we train several models to predict the category of Chinese news headlines and evaluating using accuracy to find the best one. We optimized them and saw their performance. After comparing 3 models through this project, we find that BERT performs the highest accuracy in our text classification task. However, training time consumption of BERT is also the largest in these 3 models. Under their evaluation criteria, we can see that the optimized BERT can achieve the best result with 94.69% accuracy. And here we can see the 3 accuracy of different models in the table. And we go to the future works part. The first one, we only use a part of the dataset, and the entire dataset contains 740,000 news samples. Next, we will try to apply our models to the entire dataset. The second part, more and more complex models will be applied to our dataset, such as bidirectional LSTM. When applying these models, we will try to optimize our text classification model with parameter selection. And the last part, we rely in the pre-training of the Chinese words vectors to perform the test CNN model. We extract features including words and character from so-called news dataset. And then we will try to extract more features such as n-gram. And this is all for our group project presentation. Thank you for listening.